Hi, welcome to the next video in the functions module. Here we're going to look at the vertical line test, and instead of just looking at it when we have just points on our graph, we're going to look at it when we have lines and curves and shapes on our graph. But really the vertical line test is the exact same thing. So we want to just hold our pencil, and once again we have this red pencil. You can use your own pencil at home. We're going to hold it vertically and we're going to move it across our graph. All right, so the idea is if we cross the graph more than once with our pencil at any point, then it is not a function. So if I hold it right here, I can see that I am crossing my graph here and I'm crossing my graph here. So I'm crossing it twice. Therefore, that is not a function. Okay, so let's try the one here next to it. And right away I can see there's a lot of places here that I am going to hit this graph more than once. In fact, I only need one location on the entire graph that I hit it twice to make it not a function. But this one's really not a function because I am hitting it a lot of locations here where I'm hitting it right here and I'm hitting it right here. So this graph here is not a function. So let's scroll down. We have two more graphs here. We'll use our pencil. And I'm going to pull this across my graph, again holding it vertically, the vertical line test. And I can see that actually, no matter where I hold my pencil, I'm only ever touching this blue line one time. Now here I'm touching it right here. I hold it over here, I'm touching it here. If I hold it up here, I've got it right here, but only once. There's no place where I'm holding this pencil that I'm going to touch this blue line twice. Therefore, this one here is a function because it does pass the vertical line test. Let's try this last one. Now these are lines, but there's something going on right here. So I just want to point out what this is. This is a closed dot, and this is an open dot. So what this is telling me, we see this is our x-axis. So this point right here, this would be x equals -2. So at x equals -2, it almost looks like we have this point and this point both touching at x equals -2, and you would think that maybe it would fail the vertical line test. But this is a closed dot, which means this line does exist here at x equals -2. But because this is an open dot, it does not exist here. So actually, when I hold my pencil here, and I'm going to hold it at x equals -2, I am hitting this line, but I'm not hitting this line. Same is true here. When I'm at x equals 3, I'm not hitting here, but I am hitting here, which means I'm only ever hitting at one spot on a blue dot, on a blue line, no matter where I hold my pencil. So this one is a function because no place am I going to hit my graph twice. So yes, this is a function. Okay, so that's how we interpret the vertical line test when we have shapes and curves and lines instead of just simple points. Now we want to take a look at some word problems. So I wanted to just redefine our x value and our y value for us. There are some things that we can call it. So our x value in our ordered pair is the domain. We talked about that. We talked about a little bit that it's the input. It's also what we like to call the independent variable. That's new. This one is independent. The X is in charge. The X gets to do whatever the X wants to do. It's the independent variable. Then we come down to the Y value. We talked about how it's the range, how it's the output, and it's also the dependent variable because the Y is dependent upon whatever the X is going to do or whatever the X is going to be. So the Y just has to follow along. It's the X or the domain that's really in charge. So whenever we're evaluating these to determine if they're functions or not, we really want to start with the X value because that's what's in charge. So let's look at some real world functions and see if we can determine if they would be functions or not. So here I have some hints that might help you determine if these are going to be functions or not. So the first one says, ask yourself, for any X value, could I get more than one Y value? That's the definition of a function or not, right? And then for number 2, it says to create some ordered pairs. So coming up with some examples might help you as well. So let's just talk through some of these. Number 1 says, my X value would be the number that you punch into a vending machine. And my Y value would be the candy that comes out. So if you think about a vending machine, it really works exactly like a function should work. Because when I punch that number into the vending machine, the same candy is going to come out every time that I hit the same number. So I assume you've all used vending machines before, and maybe you punch in a code. You punch in 238. So every time you punch in 238, a Kit Kat bar comes out. Every time. So you wouldn't hit 238 and the next time then a Twix comes out. That wouldn't work, right? That's not how a vending machine works. Every time you put in 238, you have to know what's coming out. Every time a Kit Kat must come out. So for any given X value, can I get more than one Y value? Absolutely not. Or the vending machine is broken, right? So once I type in that code, I know what candy bar is coming out. So that means that this one is definitely a function. So let's scroll down to the next one. The X value is the age of a student in our class, and the Y value is their height. So let's think of some examples. Now, if I have a student that is 14 years old, they might be 5 foot, 5 inches tall. So there's an ordered pair. It is very possible that I could have a student sitting right next to them who's also 14 years of age, but is 5 feet, 2 inches tall. Right? That's possible. That could happen. So here I have the same X value, but it has 2 different Y values. I have 14 and 14, so I'm duplicating my X values, and I have different Y values. So this means that this is not a function. Let's try number 3. I have the X value is the diameter of a cereal bowl, and the Y value is the number of marshmallows in your Lucky Charms. So let's just imagine we have a cereal bowl. So let's see if I can draw a cereal bowl. Not going to be a very good one. Okay. And the diameter, so the distance across here, let's say that that's 5 inches. And I pour my bowl of marshmallows, my Lucky Charms, and I count them, and I have 21 marshmallows. So there's my ordered pair. Now, is it possible that the next day when I use the same bowl, so I've got a diameter of 5 inches again, and I pour another bowl of Lucky Charms, and I count my marshmallows, could I have 26 marshmallows? I sure could, right? Because you never know how many marshmallows are going to come out. So here I have the same x values that are going to different y values. So this one is definitely not a function.